A closure is a very interesting functional programming tool. Let's see what it is. As you have already seen in the previous lecture, local variables in the outer function are visible to the inner function also. Let's take another example, a slightly different one to highlight what closures are. Let me first declare a variable in the global scope. Let's call this variable scope and initialize it to the string global scope. Alright. Now let's write a function check scope which doesn't take any parameters, and inside this we declare a variable with the same name scope and assign the string local scope. Then we write a nested function. Let's just call it f, and this function returns the scope variable that it sees. And finally the outer function returns a call to the function f. Alright. Just go through it a little slowly to understand. We have declared a function f, and just like the hypotenuse example which made a call to the nested square function in the return statement, here we are returning the value returned by invoking the function f. Alright. Cool. So now let's see what is the value of the scope variable, and of course it is global scope. If we call this function check scope, it returns the string local scope because the function f sees the local variable, right? And what if we had not defined this local variable? Then of course the function f would have seen the global variable, but that part is not interesting. Variables in local scope are interesting in context of nested functions. By the way, what we saw till now was straightforward. The twist comes if instead of calling the nested function f, we return that function itself from the outer function like this. If we call the check scope function now, what do you think should get printed? It will print the function definition of f, right? Note that we have not yet called the function. And if we make a call to the returned function, what do you think should it return? Global scope or local scope? Observe that after the outer function check scope has returned, this variable which is in the local scope of the check scope function should go out of scope now, isn't it? So what do you think gets printed? Let's print it and see. So function f still returns local scope, and that may come as a surprise. Now this happens because JavaScript functions are executed using the scope chain that was in effect when they were defined. Alright. So if you look here, this nested function was defined under a scope chain in which this variable scope was bound to the value local scope. And this bonding will remain effective whenever or wherever this inner function is called, even though it seems like that this scope variable goes out of scope when the check scope function returns. So you can imagine that if the outer function returns the inner function takes all the local context within the outer function along with it, which is always available to the inner function even when the outer function goes out of scope. And here even the parameters passed to the outer function will be available to the inner function, because after all parameters to a function are local variables. Alright. So one may imagine or say that the inner function closes on the local context available in the outer function, and that is why the name closure. By the way, closures are not just available in JavaScript, rather any programming language that claims to support functional programming. By the way, if a function returns a closure, do you think that function should be a higher order function? Of course, right? Because higher order functions are ones which either take other functions as parameters or they return a function. So this may have been a little heavy, but once you understand it, you will start appreciating the beauty of functional programming and how some of the things can be done better. In the next lecture, let's take an example of how to use closures.